Alright everybody, welcome back to Blackacre Ranch. So this doesn't look like we're at the ranch, and I know that. So the reason why we're here, we're in my kitchen right now, and we got some soil samples back. And as you know, we talked about, I think a couple weeks ago, about the NRCS, or last week, I don't know when it was. The NRCS came out and we did some soil, or looking at some grasses actually. And so I've been kind of interested in that recently. So as you know, with that, what we're trying to do is we bought 187 acres of land, and the goal was to be able to rotationally graze our buffalo and our different animals throughout all of it, to hopefully lessen the burden of having to buy hay. Okay, that's going to take the good grasses, and it means we'll probably need to fertilize and do things of this nature. When it comes to raising good grass and being in the grass business more than the meat business, it seems, you have to know what's your soil doing. All right, so if you have really good soil, you know what kind of grasses would grow best there, and two, you know what kind of fertilizer. And as I've been pricing grasses and some fertilizer, especially grasses, they are way not cheap. So in an effort to try and be efficient with our money and not just waste all of it, we took some soil samples. Now the reason why we're in our kitchen right now and not actually at the place is because I got an email with all the results, and I wanted to share them with you about the different soil tests, or about the soil tests they did and kind of how these different things went out. I want to take you back a number of weeks ago when we took all the samples, let you kind of see that video, where we did it, how we did it, and what the samples looked like before we shipped them off. And then after that's done, come back and I'll share with you all the different things that we found. All right, 2 weeks ago. After doing a bunch of phone calls, I kind of figured out how to do soil samples. You have to send it off to a place to go ahead and analyze it and tell you what you've got. So the main object is to get samples of the ground in certain spots and then send it off to a place where they do an analysis. All right. Now in Texas here, A&M does this, and so they have sent a soil sample form. You can download it online. It's actually at soiltesting.tamu.edu. Anyway, they have a form here, and they give instructions on kind of what you're doing. All right. So I would encourage you to get with whatever state agency or whatever places around where you're at, the labs, and kind of test the soil. And this is actually done in a scientific kind of way. Let me kind of explain how that happens. Really what they tell you to do is they tell you to take the area that you're doing it and break it down into bits and take what's called a composite sample. That's where you take multiple samples from a certain area, combine them together, and then send one sample representative of the entire area that you did. Okay? They tell you to break it down between 10 to 40 acres. My pasture 6 is 17 acres. Pasture 7 is around 16 or 17 acres. Okay, so they're both about the same. If I do the 10 to 40, that means I could just do a set of samples here and a set of samples there and just send 2. But I don't want to do that because they also tell you to look at the soil types. So if everything was all the same type of soil, I could just do pasture 6, pasture 7, and send it on. Okay, but it's not. If you remember our small pasture, it was really sandy. That kind of extends some into pasture 6. Then if you look beyond into pasture 6, it flattens out and you get more of a grass and more of a soil down here. Okay, now let's look at pasture 7. So pasture 7 up here on the high side isn't too bad soil-wise, but when we look down towards the lower section, we get more of a lignite hardened area. So you'll see the little brown grasses just above that area. It doesn't grow a lot of grass because it's just really a hard soil or something. So I am actually breaking up my soil samples into different areas, okay, based on that. So I've got my trusty map, and this is my geographic perfection, very much to scale, I guarantee you. But this is pasture 6, we're right about here. This area up here kind of has some sandy, and this is kind of sandy. And right here, where the buffalo have been sitting, over by the hay, that is also very sandy. I swear that's where they had the sand volleyball courts. So I'm not going to take it actually from there, but around the area is also still kind of a sandy soil. So that's going to be group A. All right, you want to separate these into what your labeling is. Okay, so that's going to be group A. Group B will be down the peninsula. Okay, so that's going to be further south. That is going to be in the far side, way down yonder. That's going to be Group B. We then have, if you remember, the lower section of 6 and 7. This is a different type of terrain, okay? It's not the same as this type, and so the soils may be a little bit different. So they said also look at the terrain, not just the soil type, but the terrain, and make adjustments, okay? So I'm going to classify the lower section all as one group and take that as a composite sample. All right, and then that fourth one was going to be over here in pasture 7, where it got kind of flat over here, where it's hard grasses and so forth. That is going to be the fourth sample. So I have those 4 to try and get an idea of what these types of areas are. We're going to go around and we're going to go get these samples of these grouping areas, and we're going to use our trusty tool. They do have tools for this kind of stuff. We're going to take these samples, put them into a collection spot, mix it around, and then take one sample into a bag, and we're going to have to label it. All right, so that's what we're doing next. So you take your shovel and you put it in the ground. They say to go about 6 inches down, and you make a V shape. Now there are different tools that you can do. There's a corer, a core sample taker, some other things, but you can easily just use a shovel. Now the instructions say go down 6 inches and then take a 1 by 1 inch sample from the center. They say to sweep off kind of the debris or the stuff up top, but don't take away the blackness or the black matter from the dead vegetation. But just get a representative 1 by 1 here, collect them in a bag. So the only thing that we had for a bag is a cube bag, but since all of the other stuff had cubes in it, we flipped it inside out to try and keep it so as untainted as possible. I hope it works. Anyway, so I'm going to break this off and then just keep the center section here, and this will be sample number 6 or 7, I don't know, whatever it is, but all in the grouping A composite.
Hi ladies. They're like, where are you going with that bag?
These are the 7 or 8 samples that we got from grouping of A. And they're in our bag here. So now I'm going to mix this up to try and get a representative sample. And we are going to put it into this, what size is this? Quart? This quart size baggie here. And we're going to go ahead and seal it up. And we will mark this as A, composite A. Here, let me, oh, thank you. All right.
You're a man who likes his hands dirty, huh?
I don't know if there's any rhyme or reason to this or how this is really supposed to work, but we've got a bunch of grasses and all right, Michelle, baggie. Alright, let's seal this down. They said get the baggie pretty full. And on the order form when you're there's a series of tests that you can actually check the box for. And we're just doing a routine test, alright? They're going to ask you things about like what kind of vegetation are you growing? Are you doing it for hay? Is this pasture? Is this a certain type of farming for a certain type of crop? So they just ask you a couple questions and then you check the box. You pay per sample as a price, at least here with A&M, and then you mail it off and they'll just send it back to you. So we're gonna mark this as A and correspond that on our sheet with A, and then we're gonna fill out that sheet as we take all these other composites. Here's the little baggie. So we need to mark A. I'll get a pen eventually. The sample, you can dry the sample to aid in the testing, and they don't want you applying direct heat, you know, kind of a thing with like a hair dryer, but you can let it air dry and then send the sample like that. So we might actually let these kind of air dry back at home or something before we actually mail it. But so far they're in their moist condition, and we'll maybe treat it like that afterwards as a dry sample. Wow, you can already tell the difference.
Oh yeah.
In this soil here. It's a lot different.
The soil looks a lot nicer though.
See the clay layer, and this is all the dead matter. Hopefully,
Topsoil, right?
topsoil is a good name for it. Hopefully it grows one day. In there they tell you not to take samples from like streams and creek beds and other things where it's just like a depression collecting water. So behind me in pasture 6 right here is where the water is, and I'm avoiding that, and I'm trying to skirt around it, not too close. But if you have a creek, don't take a sample from there, because it's obviously going to be biased from the vast majority of what the rest of the land is like, and it's not necessarily grazable land per se. So stay away from those, but just stick to the main pasture. So this one isn't quite as bad as the other one, black-wise, but
All right, so we're finishing C. That's pretty dark.
mm-hmm. Some little clovers.
Not tainting your sample at all. And here's the creek. It's been a while since we've been down here. The part that was mulched out is looking really good.
We've officially made it to D. So this is back in pasture 7 on top of the ridge, and we just came down from C coming back northward. So this is the type of stuff, and it's just hard. So some of this is just really prevalent. So I can't even get 6 inches down, and I'm not exactly the lightest dude in the world, and this shovel is just that much. So we're gonna try and find some spots to represent, but this is pasture 7, what, composite D? Thorns do exist.
Definitely.
All right, one more.
So it grows. And there's still all this clay at the bottom of it, huh?
We just wrapped up our composite sampling, so we have our 4 groups, the A, B, C, D. And these are the baggies. So this is A, more sandy-like. Here's B, kind of almost more normal looking, some clay. This is C, this is super dark. I mean, this is just really nice. And then this is D, which has, you see the lignite and some other iron-like stuff. You know, I'm not a geologist, ask my brother. But anyway, there's more of that. So if you look at them, you can actually see a color variation between them. More of a sand brown, a darker brown, rich brown, and actually a reddish. All right, so when we sent this down to A&M and mail it down there, they do their thing, and they send us back an email with the results, okay? And this is a sheet of what it kind of looks like, all right? And you'll see there's a bar graph, and they kind of have some representation there being all scientific. But you'll see over here on the side, these are a listing of all the different types of elements, stuff they're looking for, okay? And you can pick what kind of test you want. So they'll do more than others, but we separated this, of course, as you know, into 4 groups. All right, the soil seemed to be different across all the 4 groups, and when we looked at these results, they actually are, okay? In general, they all need about the same nitrates, but they all differ, okay? The bottom section C, that had the most normal or adequate of all the soils in typical, actually has no need of limestone, things like that. But it's interesting how even in 6, when you go from the first A section up top to the B section, just even 100 yards difference, 200 yards difference, they have different requirements, okay? And so that kind of helps me know that, one, I think we chose pretty wisely, because if we just took all 30 acres, you know, we really want to kind of know what the differences are. If I had taken one large composite of all 30 acres, I might find myself overpopulating with a fertilizer in this section, underpopulating in a different section, wasting money in one area and not utilizing it better in a different area. So this gives us that ability to actually get it all hopefully dialed down and accurate to the specific needs. All right, so anyway, if you're interested in grasses, stick with me, okay? I'm gonna try and make this educational as much as it is boring. You know, I'm coming from a background, I'm not the soil dude, so I'm gonna kind of read to you what some of these things do and might enlighten you, kind of things to think about. But let's kind of go through some of these, and I've got through trusty Google a printout of different things about what all these elements do, okay? So in general, across all of our samples, they all looked good for calcium and magnesium, okay? Those things across the board, they were at the critical level, not a problem, they were doing fine, okay? What does calcium and magnesium do? I hadn't a clue, all right? So Google says calcium helps provide plants rigidity. They use calcium to create carbohydrates like cellulose and starch. It improves soil structure by helping soil particulates stick together. Symptoms of calcium deficiency in plants usually appear on new growth, okay? We're good on calcium. Magnesium. It activates enzymes that promote healthy growth and strengthen cell walls in seeds. It says it improves germination of the seeds. It provides some of the amino acids used in protein production. All right, so that's it. All right, so across the board, A, B, C, D, we all have good calcium and magnesium. That's good. Now, something we're lacking across the board is nitrates, and I don't doubt that's probably a common thing. Nitrates, if you want to know what those things do, it's nitrogen. So it's used as food by plants for growth and production, okay? Nitrates is plant food. That's what I'm getting from Google, all right? And we all know you trust everything on Google. All right, phosphorus. Must have phosphorus for normal growth and maturity. Phosphorus plays a role in photosynthesis, respiration, energy storage, and transfer, cell division, cell enlargement, and blah, 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 all these other things. Summarize it, helps it grow. I don't know, okay? Potassium. Potassium across the board is fairly consistent, fairly weak, except C had tons of potassium. You can see how much each pasture is different. A was good in phosphorus, bad in potassium. C is good in potassium, bad in phosphorus. So, potassium, along with nitrogen and phosphorus, it's one of the essential macronutrients required in the largest quantities by plants for growth and vigor, whatever that means. Okay, so it's good, all right? Next one's sulfur. Sulfur, we didn't ever meet the critical level on any of these things, really, I don't think, for sulfur. So sulfur levels on a soil test indicate how much precipitation an area receives, or at least how much water is running through the soil profile. So if sulfur is low, that means it's getting leached out, and in those types of soils, the majority of sulfur is actually supplied through organic matter. All right, so I'm guessing that means where we have low sulfur, a lot of stuff's just bleeding through and maybe not sticking around so much. I don't know. It tells me to add sulfur, I'm gonna add it, so whatever. That's the sulfur definition per Google, all right? Now, when we look at these last little bits, this last little section here is limestone. And I think when people fertilize, I hear everybody talk about you need to add lime. You need to add some more lime and lime and lime. So limestone, they said every place needs 1 ton per acre of limestone. The only pasture that doesn't need limestone is C, and that's good. I don't want to add anything more there than I have to. It's too hilly. But limestone, per Google, When the soil in your field or garden reaches an acidic pH level, certain nutrients such as aluminum, manganese, calcium, magnesium, phosphorus, blah, blah, iron, elevate to toxic levels. So not only will limestone prevent the buildup of these nutrients, but it will safely improve the calcium level as well. When lime is added to soil, these compounds work to increase the soil's pH level, making it not so acidic. So that, of course, brings us to the pH level, all right? pH level makes a difference in the soil, all right? Certain grasses can grow better in certain pHs. The grasses can absorb better nutrients in different pHs and so forth. Weeds might tend to do better in certain pHs. So by affecting the pH balance of your soil, you can go ahead and actually have better grass. It affects the availability of all plant nutrients. So here's the range you want. Between a pH of 6 to 6.5, most plant nutrients are in their most available states. All of 6 on the upper section was 5.3 on the pH. C down below was 6.5, right? That's where we have our best growth of all of our plants, and maybe that's partly why. D was horrible. It was 4.5. We barely have grass suitability according to this thing. So what's the big deal, okay? Plants can grow at different pHs, all right? And so when I was looking at this, some people had said, well, grass doesn't grow below 5, or grass needs to be above 7. I haven't seen anything that says that. I don't know. I mean, it's not seeming what Google just told me, but what it did kind of say, weeds versus plant growth for pH, it said most broadacre crops are suited to soil pH above 5.5, okay? In more acidic, meaning it's a lower number, weeds can take advantage of the soil moisture and nutrients to grow and set seeds, adding to the soil weed seed bank. Weeds do not usually prefer acidic soils, but they are just able to take advantage of the reduced competition for the resources. So if we add lime, what you're really doing is raising the pH, and you're allowing the crops to take more, to not be as disadvantaged, to have a better chance of overcoming the weeds in that pH level. So a low pH just really hurts the ability of the grass to beat out the weeds. A higher pH above 5.5 helps the grass overtake the weed. That's pretty much what it is. Okay, so anyway, this is a lot of information on soil. This is kind of what we've garnered from this. Our next steps now is to go and figure out how in the world do you buy fertilizer, and how do we satisfy all of these things, okay? Just as for perspective, limestone is 1 ton per acre. So if I'm going to put this over 16 acres, I need 16 tons. Gosh, that seems like a whole lot. I don't know how much that stuff is. Anyway, on the other hand, nitrogen, nitrates, 55 pounds per acre. Phosphorus, 20 pounds per acre. That's a big difference from 1 ton per acre, okay? So it is definitely going to be heavy on the limestone, not so much on the nitrogen, phosphorus, and all that other stuff. If you have any suggestions, I really would appreciate you letting me know. Is there a difference between really getting the granular or hard stuff fertilizer that you use a broadcast spreader on the back of the tractor? Should you get it in a liquefied form that's a concentrate potentially? How would you guys do it? How is it best to do? Hopefully it's not a ton of money. So anyway, appreciate you joining along. This was the big soil stuff. We kind of geeked out on a lot of Google and test results, but hopefully you enjoyed it. Now you know what we're doing still behind the scenes, trying to learn about fertilizer. All right? Catch you later.
With you, I wanna stay with you.